Okay, hopefully you have finished this and you're coming back to check all of your work. If you're still stuck and a little bit lost, then what I suggest is for you to have frequent pauses so that you can attempt the rest of it once you have the preliminary information. So our first goal was to calculate the focal length using one of the formulas above. Well, we have the distance of the object. We thought, well, okay, here's the focal point here, and here's the focal point here as well. But I don't have the distance of the image, so I can't use this formula. So I have to use this formula. The focal point is going to be half of the radius. If my radius is 20 centimeters, my focal length will be 10.0 centimeters. Okay, so now let's go ahead and draw this. Remember, we're using a half scale, and we're going to draw the two light rays for this scenario. So let's go ahead and measure everything. And remember, we're cutting everything in half. So the distance of my object will be 15 centimeters. So put a line right there. The height of the object is 6, but I'm cutting it in half. So I'm going to actually just, so I don't get confused and don't forget, I'm cutting everything in half. My focal is going to be at 5.0 centimeters, just so I don't forget anything. Radius is not really needed anymore. So at 15 centimeters, there's my object. The object is 6 centimeters, but we're cutting it in half, so it's going to be 3 centimeters high. Try to be as precise as you can. Focal point is going to be 5 centimeters. It was originally 10, but we've cut everything in half. So there is my focal point. So now we're going to draw the two light rays. Our two light rays come in, they come in first one is going to be coming in parallel. And remember, we draw to the line that's perpendicular to the principal axis and not to the mirror. And this is going to exit through the focal point. Like that. Our second ray of light will now go through the focal point to the line, not to the mirror, and then it's going to exit out parallel. Okay, so now what we can do is we can find this right here. This is where the lines intersect. This is where my image will appear. I'll draw a line going down here. So let's go ahead and label a couple of these things. Here's my object. Here's my image. So I have the distance of the object. I have the height of the object. So the height of my object is equal to, in this case, 3.0 centimeters. And the distance of the object is equal to 15.0 centimeters. What's my measured distance of the image? So this comes out to be 7.6. So the distance of the image is equal to 7.6 centimeters. But if you remember, we are actually half scale, so I have to double that. And that will give me 15.2 centimeters for my measured distance. What is my measured height? Okay, let's go ahead and calculate this. The measured height of this is going to be about 1.5 centimeters. So remember, we have to double that, so it's going to be 3.0 centimeters. Now, here's something interesting. It's actually not 3.0 centimeters. If you recall, this is an inverted image, so what has to be done to this? Hopefully you remembered that it has to be a negative 3.0 centimeters. Okay, so let's go ahead and do the calculations down below here. We want to calculate the distance of the image, okay, and we're going to do that using the lens mirror equation. So let's show our work over here. This is the lens mirror equation. So I have 1 over f equals 1, the inverse of the distance of the object. We are trying to solve for this right here. So I want to subtract it from both sides. So 1 over f minus 1 over di will equal 1 over, do, 1 over di. Okay? So we just subtracted this from both sides. And let's go ahead and plug in my numbers. Well, remember, we're using the actual numbers, not the have numbers. So we're using the focal point of 10, and we're now using the distance of the image being 15.2. Oh, and no, distance of the object, which is 30. So we have 1 divided by the focal point, which is 10, minus 1 divided by the distance of the object, which is 30. Okay, again, we have to take the inverse of that, and this comes out to be 15. 15.0 centimeters. My drawing was pretty close. Maybe yours was even closer. And this is the calculated, so it should be at 15, but because of slight irregularities in your drawing and you have to measure these things, this is not always going to be exact, but it should be close. Okay, the calculated height of the image. It says we can use the magnification formula, combine one for this right here. So we have hi ho equals di do. We're trying to solve for this, so we're going to multiply by the denominator of ho on both sides. So hi will equal negative di over do times ho on both sides. So when you plug in your calculator, and remember it's going to be negative, or it's going to be negative of whatever. So if it's comes out to be negative, it'd be negative times negative, or if they're all positive, it'd be negative times positive. So distance of the image, we just calculated this at 15. We want to use the calculated, not our measured, by the way. So 15 divided by the distance of the object. Distance of the object is 30. Times the height of the object, which is 6. 0.5 times 6 would give me 3, but it's actually an inverse of that because we have the negative as well, so it's going to be negative 3. So the calculated is going to be negative 3.0 centimeters. That was actually our measured, so we were very close. We were actually precise on that one. Last one is the magnification. Use both magnification formula to determine the magnification to show that they are the same. So we're going to have two equations here. Okay, we're going to have magnification is equal to hi over ho. Magnification is equal to negative di over do. Okay, we're using all our calculated values. So the height is 15.0. The height of the object is, the height of the object is going to be 6.0 centimeters. Okay. Oops, height of the image, my bad. That was the distance of the image. The height is going to be negative 3.0 centimeters. The negative distance of the image, so the negative 15.0 centimeters over distance of the object, which is 30.0 centimeters. These two should come out to be the same. 3 divided by 6 is equal to negative 0.5. Centimeters cancel. And 15 divided by 30, this will give you negative 0.5. Centimeters cancel. So both of these will show that that is the correct answer. What does this mean? The negative means that it was inverted. The number is the magnitude of the magnification. If it's greater than 1, that means your image is going to be larger. If it's less than 1, it means that your object is smaller. So our image is about half as small as it is half as small as the original object.